thank you so much for joining for this session, guys. It's maybe morning or evening your session, so thank you so much for taking time out and then spending your time on learning something new. Right. So today we are going to talk about building your first microservice with .NET. Right. And whatever I'm going to show today is all available as part of a Microsoft Learn module, which is present in the link here. I'll also share these links in the chat window as we proceed. Right. So quick introduction about myself. I know Swaminathan has covered a bit. So yeah, I work as an architect at Maersk. Currently, I'm working on building microservices and deploying them on Kubernetes and using Azure PaaS services, etc. And I'm also Microsoft MVP and a member of .NET Foundation. I organize a couple of other meetups in Bangalore, which is called Bangalore .NET User Group. That's what is B.NET and X-Hackers. And I'm also co-organizer of Bangalore Azure Meetup groups. So I kind of write blogs occasionally now, and then speak at these different events, meetups, and local developer conferences, etc. And photography is my other interest. And those are my social handles, so you can feel free to follow me in whichever you are comfortable with. Right. So yeah, so the agenda for today is about microservices, right? So first, let's get an understanding of what are microservices, right? So we need to understand what is that, and then why microservices, etc. And then we'll start with the demo aspects of it, right? Let's understand how we can Dockerize your first microservice, obviously written in .NET. And then let's also understand what is an orchestration here, and then why do we need a microservices orchestration? And let's see how we can use a Docker Compose as a technology to orchestrate the multiple containers. And finally, we'll also try to run the same microservice in Kubernetes environment. Yeah. So I would like to make it more conversational also. So feel free to raise hand and ask questions. I'll keep a tab on the chat window also here. Right. If there are any questions, please raise hand, and then we could have it discussed. So just a sort of a few prerequisites if you want to follow along, if you want to try these out on your own. Right. So first thing is you need to have some familiarity about the command line based applications to run a few commands around .NET or Docker or Kubernetes, etc. And then you also need to have some familiarity about the basic Docker concepts. If not, we'll also help you understand through this course, right? Course of the session, right? And then of course you need to have a .NET SDK installed on your machine. And these are other tools which you would need. So Docker Desktop, and then Visual Studio Code is the IDE or the editor what we'll be using today to run through the demos. Right. It's going to be more of demo heavy, so I'll run through some of these presentations initially for a few minutes to level set all of us about the microservices and Docker and everything. Beyond that, it will all be mostly on the demo side. Okay, so and these are some of the learning objectives what you would get by the end of this session. Right. Okay, so what are microservices? Right, this is a very hot topic these days, right? So today, most of these application development IT entire landscape is managed by the cloud, right? So that means the modern cloud applications need to be fast, and then when I say fast, it's by performant, and they need to be agile also, right? They need to be more agile, and then the release to market should be very minimal, right? You need to be able to push your functionalities or the product changes as frequent as possible, right? And then it also needs massively scalable, right? Because you'll never know when your application or your product would become hit, and then you need to have a dynamic scaling available for that, right? And of course, any system we build has to be reliable, right? But these are not just microservices. These are just about what are the kind of IT landscape or the development landscape we are in currently, right? So now, how can we address all of these things? That's where we would take help of the microservices architecture. Right. So with microservices architecture, as the name tells, so it's going to be multiple microservices, basically. So traditionally, we've all been developing and deploying a monolithic application, so to call it, right? So that means there will be only one application, or be it a website or be it an API or whatever, right? That could be one application, and which would comprise a lot of modules inside it, right? So it will be more of you could use a modular architecture, and then you could split your different functionalities into different modules within the monolithic application. Right, and that's how traditionally all these larger applications have been built and then deployed, right? So it has its own benefits and of course a lot of cons now, considering the way how we are moving into the cloud and then trying to address these fast and agility and the scalability, etc. Right, it has its own challenges, right? So now what if we were able to decompose that entire monolithic application, which has maybe 10 to 15 modules, into different microservices, right? So that will bring in a lot of goodness for us. So what are the things it could give? So basically the microservices, so these are some of the qualities of microservices, not a comprehensive list, right? I try to capture some of them here. So microservices are technically very small and they are independent and loosely coupled. So what I mean by that is, let's say in the example of an monolithic application where I mentioned about 10 different modules, right? You could have technically 10 different microservices created, and each of them can be built separately, deployed or tested separately, and deployed separately and independently, right? So that reduces a lot of friction, right? As you can imagine, if it's a single big bang application, you need to have a lot of coordination among different teams to follow through your release cycle, and then ensure there is less regression, etc., right? So all those can be avoided if you're going with the microservices, right? And also each microservice would have some code base, separate code base, and then each can be developed by a small development team, right? And also they are deployed independent. That's what I just mentioned, right? And we don't have to really worry about deploying other pieces of the application, right? Let's say you're working on features A, you can go ahead and deploy that feature which is part of a microservice A, irrespective of whatever the other team is doing on microservice B or C or etc. Right? And microservices also are responsible for storing their own data. So that means basically these works on a concept called bounded context. So you will define who owns the data, and then you will expose an API or a microservice on top of it, and then the data interactions would happen only via microservices, right? With monolithic, what we used to be like an database calls, so database joins, there will be a lot of database joins which is happening, right? So all those would go away. Somebody's unmuted. Can you please mute yourself? Okay, thank you so much. Yeah, so what I was saying is about the database part, right? So traditionally, in a traditional monolithic application, there will be one application on one database, and all the different modules would reach out to the same database or different tables within the same database, and then they will write different joins if you're not a BMS, and then we'll get the data, right? But with microservices, what we also would attempt to do is to have every service should have its own database, and the ownership of that particular data, be it creating or deleting or modifying or retrieving, everything is residing within that microservice. Right, and they all communicate with each. Of course, since we are splitting things into different microservices, right? What used to be like an function call or a method call in a monolithic application, right? Now it becomes like an API call, or it has to go outside of the current process boundary, right? So how this communication could happen? There are well-defined API specifications and things available. If you are using REST, you would use a REST-based communication. If you have something like gRPC, you can also use gRPC-based communication for that. But yes, all these are more like contract-driven communications, right? And this is one part if you're going with HTTP based communication. There's also another way of doing with events. So that's more of a bit of an advanced level of microservices if you have to go, right? And of course, then one of the other important benefits we might get out as a byproduct of this is okay, I see that someone has muted me accidentally, I believe. Yeah, so what I was telling is about the polyglot programming, right? The moment you are able to have different microservices handling its own functionality, right? It also brings good flexibility for you to use the right programming language of choice for that particular microservice, right? It need not be that everything has to be written either in .NET or in Java or Go or whatever, right? Whatever a programming language can solve the problem which that microservice is trying to address, you will have the flexibility to use them. Right? This is one very great benefit you would attain if you are able to follow a microservices architecture. Right, and with that, and then again, still why microservices, right? I think we just talked about some of these. We can scale them out and independently, and we can test and deploy them and then manage them independently. There is not much of an friction between multiple teams or multiple teams working on a single code base and things like that. All right. And just to give a brief about how the deployment and the approach would be here, right? So to my left is the monolithic deployment approach, where this is what I was just explaining also, right? We will have a single application that will comprise multiple modules inside it, and then we would deploy that into one of an VM or a server. When you want to scale this application, what we will do, we will create another VM or so, and then deploy the entire application, and then we would put a load balancer or whatever on top of it, and then that's how we will achieve the scaling, right? When we want to do a scaling, we need to deploy the entire application in its entirety. That's one of the important things to be noted down there, right? But now looking at the microservice application approach, which is on my right here, right? So you will have, if your app has multiple components, each component will be a different microservice, and each will be deployed and then scaled. So for example, talking about an example of an e-commerce portal, search is something which would be very heavily used, right? Everyone will go and search, but not everyone would go and buy things, right? So you will know what kind of functionality in your application can be scaled higher versus what can be scaled down and things like that, right? You will be able to do those scaling aspects. You can choose different sort of scaling with the microservice architecture. Right, now are microservices just only for containers? That's one of the common questions we all have, right? So what role do containers play here, right? So the answer is microservices and containers go hand in hand, but containers are not the only way to deploy microservices based architecture. It's, for example, if you're deploying on Azure, right, you could use Azure App Service also, or Azure Functions, and then you can run different microservices there, right? But where containers help us here is containerization is basically an approach to basically have a single package created where your application code plus your dependencies, everything will be baked into a single as a single package, right? So with containerization, achieving the scale and different other things are much easier. So that's why it's becoming like a de facto means to containerize your application or an API and then deploy it when you're dealing with microservice architecture. But just to be aware, right? So microservices doesn't mean you have to always containerize and then deploy it. Okay, it's an architectural principle which should enable you to achieve all of these goodness what we just talked about, right? And one of the ways to achieve that is by using containers. Okay. And yeah, so now talking about containers again, we would have heard about Docker, right? Because Docker is one of the most popular container technologies, right? So Docker is an open source project, and that kind of revolutionized the way how people interact with the containers or create containers, etc., right? And there are also other container runtimes available, but yeah, Docker is one of the most easiest thing to get started, and then a lot of people resort for Docker. And now talking about deployment models, right? So here, what you would deploy is an image when you're dealing with a Docker-based deployments, right? So an image, what does an image contain? So typically, if you're from a .NET background, you would have known that when you build an application, it generates DLLs, and then maybe you create an package, maybe something like an MSA you will create, and then you'll deploy that into your web servers, right? Or if you're from a Java background, maybe you will create something like a jar, and then the jar would be deployed into your Tomcat server or wherever, right? So the responsibility of the application team ends in just ensuring the code is building, and then we're able to get a package out of it, right? Be it jar or MSA or whatever, or any other thing according to your programming language of your choice, right? But what we were missing is the operational aspects, right? That means the runtime of that particular image. So where is that image going to run? Let's say if you're in .NET, if you build an image with .NET Framework 4, and if you're the target machine where you're deploying it, if it doesn't have that image version, or not the image version, sorry, the framework version, then your application will not run, and then you will hear runtime issues, right? That's typically what everyone says it works on my machine, right? So when we did it, we had all the tools in our machine, so it works, and then we try to create a package, and we go and deploy it, and then everything breaks there, right? So that's what we've been doing traditionally. Now with Docker, or when you talk about the image, Docker image, it will not just have only your application code, it also have your code plus the dependencies. So everything you will bake it into a single unit called an image, and that image is what would be run in a container, right? So image is like a snapshot you can think of, and container is the running instance of that image, right? And now, how do you create an image? Right? Like I said in the previous example, if you have to create an MSA or something, you will have some sort of a scripts to create where you will define the instructions, and then that script will run, and then you'll create a package, right? If you're from Java, maybe Maven or Gradle or whatever scripting tools you can use, and then you'll create those packages. On similar lines, if you want to create a Docker image, Docker file is the way to go. Right? So Docker file is where you will mention all the steps in details and what are the things you are going to create as part of this particular image. And when you do a Docker build, these set of instructions should be executed one by one, and then the image would get generated. It will show in the demo on how this entire thing works. And now, so why building microservices in .NET? I think .NET is one of the most popular framework, runtime, and tool, and everything, right? So, and you can also build a lot of different workloads in .NET. If you've been traditionally building only like in Windows applications, or traditionally building only a web application, right? There are more to it in .NET with .NET Core, and now it's called just .NET with .NET 5. Right, so it's basically cross-platform, so you can run on Windows, Linux, Mac OS, and everywhere, and you can build cloud-native microservices or web applications or client-side UIs, etc., using Blazor, or you can also use cross-platform mobile applications using Mavi, and a lot of options are there. So you just basically need to learn one framework or one language, which is C# or F#, and then you can cater to all of these different workloads. Right, and also from the performance perspective, also there are tech empowered benchmarks are available, in which ASP.NET Core Server as a backend is performing much better than a lot of other popular frameworks too. Right. Okay, so now quick check on the knowledge. right? So what I would tell is, so let's take over this question, right? I'll just post the message here in the chat window, and whichever you think is the right answer, you can just put a thumbs up there, because I don't want everyone to type A, B, C, D, or so it's going to be too much. So I will just say 4 messages, whichever you think is the right answer. You can just give a thumbs up to that. Oops, there was a typo there. We'll just give maybe not 1 minute, maybe 30 seconds or so. Go to the chat window in the Teams, and then you can just give a thumbs up for whichever thing you think is the right answer. So which of the following scenarios would be a candidate to become a microservice? Right? Is it a web API that returns a list of pizzas? Okay, I see a lot of people are typing in. Looks like my message didn't come in the chat already. Or a web API and a website that return and display list of pizzas, or a GitHub Actions used to deploy a website, or a Docker image. Right, I see a few A's and B's, and okay. Okay, I think others can just give thumbs up to the existing messages because it's getting flooded there. Okay, so the right answer is A, right? Because we're talking about a web API that returns a pizza, right? So like I talk about in the Microservice architecture, you need to decompose your things. Right? If you look at between A and B, B says a web API and a website. That means two things are clubbed under a single application or so, right? That doesn't really quite qualify as a microservice. So a web API, which is nothing but a REST endpoint or a REST API that returns a list of pizzas, is something which is an ideal candidate for making it as a microservice. Right? And then the second question is about what purpose does a Docker image have in a microservices architecture pattern? Right? Is it just a text file with instructions on how to build a microservice, or a Docker image is a static representation of a microservice, its configuration and its dependencies, or Docker images allow hosts to perform load balancing and routing? Any quick answers for that? I don't know. People are still typing. I'm not sure if it's for the first question or second question. Okay, so maybe I'll just so Docker image is a static representation. Like I said, it's a snapshot, right? So it's a static representation of a microservice, its configuration and its dependencies. That's what a Docker image comprises of, right? And now, why would a developer write a Docker file? Is it to create the initialization routine for the Docker engine, or to create a text file with instructions on how to build a Docker image, or to create the code to run the microservice? This is the last question, guys. Don't worry. I know it's end of the day, at least in India time zone, and maybe for us others it will be start of the day. So B. Okay. Yeah, that's right. So B is the right answer. So basically it's to create a file with instructions on how to build a Docker image, right? So with that basic understanding, let's move on to the demo aspects of it, right? We'll start with the so basically in the prerequisites I talked about different tools. I'll just quickly give a walkthrough on what are the different tools I'm using, and then we can get into the actual demo. Right, so first thing is VS Code. Yeah, so first thing is about .NET SDK, right? So once you install .NET SDK, you will get something called .NET as a CLI here, and then you can just say .NET, and then it gives you different options, right? So to understand what are the different SDK versions available in your machine, just say .NET list SDKs, right? This is the command which I just ran, and then these are the different versions what I have on my machine, right? And if you're just installing from the latest one, then you will just have maybe 5.0 point whatever the latest one, right? And where do you go and install .NET from? So the easier way to remember that is just go to .NET .net, right? That's the URL. You just need to type in the browser, and then that will take you to the .NET's documentation page, right? And from here you can go ahead and click on download, and then download the SDK, right? And it also has all of other resources in .NET, right? So if you come down, you also have an option to learn .NET and get started in your in the browser and everything, right? I'll talk about these resources in a while. Now going back here, yeah, so first thing is, yeah, we ensure .NET is available. And now what does the CLI do, right? So you can just do a help, and then it says all the different commands, whatever is available. Let me increase it so that it becomes more readable. Yeah, so these are the SDK commands, like what you see here in this section, right? SDK commands. So you can add, build server, clean, help, blah, blah, blah. Different other commands are available to do different operations, right? So first thing, what we are interested now is this guy. So who is this? This new, right? So we are going to create a new .NET application, right? So let's go ahead and do that. So .NET new, and then what does new take, right? So we don't know. So we'll just click new, and then it should list you all the different templates. So basically these are like the project templates, and then this will get you help. This will help you get up and running with a specific application in a much faster way. Let's say if you want to create an web API, right? So that particular guy should be somewhere here. ASP.NET Core Web API, right? Web API is nothing but a REST service. If you want to create a REST API, you call it as a web API in the .NET world, right? This is the template what you would use. And if you want to use something like a Blazor, right, which is for creating your client-side interactive applications, right? So you've got templates for that. You can use Blazor Server App or Blazor Wasm App, depending on what kind of workloads you want to run, right? So like this, depending on your need, you can choose the corresponding template, and then it will create the base application for you. So now our interest is creating web API. So I'll just say .NET new web API, and then dash o is nothing but in which folder I need to create it. So I'm gonna say what is that? Microservices live demo, right? So just do that. It's going to create a new web API project for me with all the relevant code needed to run that particular project. Okay, I see a comment telling your screen got freezed. Is it still frozen, or are you guys able to see it? Rashmita or Vivek, can you guys confirm?
I can still see the screen. Try just changing to the next slide. Let me see.
I'm in a command prompt now. You should see only a white screen now.
Yeah, I can see the
It's
white
changing.
screen. Yeah, it's
Okay,
It's
changing.
changing.
Yeah.
thank you. Okay, maybe it could be a momentary issue for someone then. Right, so let me go into this particular folder where we just created this in VS Code as a browser. All right, sorry, as an editor. This VS Code, come on. Okay, it's gonna be. I think my screen is freezing a little bit. Maybe I'll turn off the camera and then I'll continue with just the screen share. Okay. Okay, so there you go. I hope the VS Code is visible now. Right. So this is the project what we just created, right? So what it did is created something called controllers, and then we have this obj properties, app development, JSON, blah blah blah, right? So what's important is first thing is about a CS project, right? So every .NET project what you create will have a .cs project file, and this is where the project metadata is saved. Right? So here we say this is the project SDK type. This is for the .NET SDK to understand what kind of build it needs to run and what kind of tools it needs to use to build this entire application, right? And then this is the framework version which says .NET 5.0. That's the SDK which I have made as default, so I've created with that. And then these are the other NuGet packages, right? So that's what I have here. So this is one of the NuGet package which is used to generate the OAS, Open API specification, like a Swagger UI and the URL, or the Swagger API specs from the controllers. Right, this is the package which is added. So if you are from a different background, like if it's Java, you would have something like an Maven. From Maven repository, you would be pulling a jar file, right? So it's something similar to that. So here we call it as a NuGet repository, and these packages are pulled from that NuGet repository. Right. Okay. So now this is the CS project file, right? And then if you look at the program.cs, that's the entry point where we have the main function, and here is where we are telling the .NET runtime to create a host builder, right? And what it is creating is a default builder within web host defaults. So there are different things which are run under the hood, right? And what are the things what are the things it is running under the hood is all mentioned in the startup file, right? In the end, it will use a startup, and in the startup is where we will give a lot of collection. We will have something called service collection where we'll specify what are the services which need to add as part of this particular application. Right now, moving to the startup, if you look at it, there is this configure services method. That's where if you want to add any controllers, or if you want to add any other workload like adding a razor page, etc., right? You will see this section being different for different types of workloads. Right? By workload, what I mean is the kind of application what we're creating. Right? This is a web API. So if you create something like a razor page, which we will see in a few minutes, right? You will see this is being different there. Okay. So and here is where this add swagger gen is added. That is what is going to give us the swagger spec for our API, right? And if you want to customize any of the configurations of the application builder, this is the section where you will go and do it. All right, so this is where the startup and the controller is the actual REST API controller, right? And this is where the endpoint would be exposed, and then when you hit that particular endpoint, you'll get the data back. And so currently we have only one endpoint to just get, and as you can see, the route is mentioned as controller. That means you'll have to access this by using the controller name, all right? So let's go ahead and quickly run this. So now I'm in Microservice demo, right? So I'll just say .NET build, right, just to build the application, right? If you do .NET run, it is going to build and then run, but I just wanted you to be aware of these commands. So just do a .NET build. It will first do a NuGet restoration. It's similar to your whatever Maven repo pull or other things like that, right? It will try to resolve the dependencies or download the dependencies, and then it will try to build the entire application, right? After this, let me just say .NET run, and then it should run the application. And to access what it's created, let's open the browser. So basically, which is running in this URL, and when I go there, it will just say that because it doesn't have any UI. So you can just go to weather forecast, and this is the JSON what is being returned from this API controller, right? This is pretty much a static data what's present there inside here, right? Whatever the summary it's mentioned here, it is just returning the entire thing with adding some temperature and things like that, right? So now, if you want to look at the Swagger spec for this API, right? How do you, if someone wants to consume this microservice, how will they know what is the request and what is the response, etc., right? That's where this Swagger spec would come into picture. So this is auto-generated one. So you can also go ahead and check that this is the endpoint which says weather forecast, and then this is the response which is the microservice is going to give, right? So that's how we could get started with our very first microservice per se, right? And now let's get into a little more. I'm just trying to move this guy out. Okay. Yeah, so this is the basic microservice. So now for this demo, or the entire demo of how we want to Dockerize and then deploy it into Kubernetes, etc., right? We are going to use another application. Okay. So the code is all available here. So basically, whatever I'm telling here, right? Okay. So a couple more things before I get into the full demo, right? So like I said, dot.net is the homepage where you can go ahead and download the .NET SDK, .NET Runtime, etc. And then if you want to understand about .NET documentation, you can go to docs here, which I have it already opened, right? If you go there, you can find out neat documentation for all of the different things what you can do with .NET, right? And here also you have the choice of programming languages, and then you also have different workloads created like web applications, microservices, game development, cloud, IoT, machine learning, etc., etc. Right? This is a good starting point for anyone to get started with any of these in .NET, right? And the next one which I wanted you to be aware is something called .NET API browser. So let's say if you want to write a particular code in .NET, right, you need to know what kind of namespaces you will be using and what kind of packages you need to import, etc. Right? So here you can go to .NET API browser, and then you can choose whichever version of .NET you want, and then you can just, let's say if you want to do some JSON manipulations, right? Just go ahead and search for JSON, and then it will return you all the different APIs which has JSON functionality in it. Right, so this is another thing which would be very handy if you start writing code in .NET. Now, whatever I just showed till now, right, by start viewing a .NET new and then running everything, all these are step-by-step mentioned here in this link. So I'll share all these links as in the chat window before then or by the end of the session or during the Q&A session, right? You guys can take a look at that. This is what we just kind of completed it. Now what we would do is we'll start with another module, right? So in MS Learn, there is good there's a good documentation and then good learning path available for anyone to start building the microservices, right? I just pinged that link already here. So this is what we're actually going to do now, right? So I don't want you to just do it side by side. Just please pay attention to what I'm doing so that you're clear on why we are doing certain things, and then you can always go back and look at this and then start working on this. Okay. So yeah, so to start with, there is already this repository is already created. So I'm going to do a Git clone of that, which also I think I've already done it. Yeah, so I must done .NET microservices, right? So once you do a Git clone, this is the project structure what you would get. So forget about these things in green, which are like something newly added after I cloned it, right? So when you create it, you will not when you just clone it, you will not get these two folders, right? So this particular application, let's run through this application first, and then let's go into the Let's go into the details, right? So this has two projects. So one is a backend project, which is like an API, and then the other is a front-end project, which is the actual front-end, right? The front-end here is created using something called Razor Pages. Razor Pages is one of the ways to create web front-ends using .NET, right? This is a server-side component, or it follows server-side rendering basically. So now let me quickly show you the application, what we are going to use, and then we'll see how we can Dockerize it and etc. etc. But first I'm going to run the .NET backend. So once you pull it, or once you do a clone, do a .NET build, it will restore all your NuGet packages, etc. And then just do a .NET run. And that should bring up the backend. And just once that is up, then I'll also do a .NET run for my front end. Right, so as you can see, this is where the ports, this is where this particular API is listening, HTTP 5900, and this is the HTTPS version of it. And here is the front end where it is running on 5902, right? So now when I click the front end, and it should show. So this is the basic pizza kind of an application, right, where we have the pizza name, the ingredients, cost, and in stock or what, right? So how this is built is, this is the front end application built in Razor Pages. I'll also show you the code base in a while. And then this Razor Pages is talking, this Razor Pages application is talking to the backend, right, which is the backend web API, right? If you want to just quickly check only the API alone, so just click on this and then say Swagger. I hope Swagger is available. Yeah, so Swagger is there, the same thing, right? What we just saw for the weather forecasting, it's the same thing as what we have for the pizza as a controller, pizza info as a controller here. Right? So this API is returning these things. So now if you want to check the output, so just say pizza info, and then you should see the JSON, right? So basically this is the same JSON data which is represented in the tabular format here, right? So that's the basic application with two different components. One is a front end and one is a back end. And then let's see how we can Dockerize it and then run it within Docker. I hope my pace is good. If in case you guys feel it's too fast, let me know. I can slow it down a bit, and then if there are any questions, please ask or raise hands, and then I can take it up and then move forward. Okay, now going back here. So let me clear these things. So now let's go back here to the tutorial, right? So that where we building a Docker microservice. So we just did a git clone, and then now is where we have to create a Docker file, right? Okay, there is someone who is asking what is the difference between .NET Framework and .NET Core. Okay, that's a very interesting question. See, up until .NET 5 was released, right, there were two different versions of, or two different, in two different ways, or two different frameworks available, if you can call that way, right? So .NET Framework was the one which was initially started, I think, which had .NET Framework 1.1, 2.2, 3.5, etc., etc. And .NET Framework 4.8 is the one which was the last version, if I'm not wrong. Right. So .NET Framework was always meant for Windows-based workloads, right? It was not really a cross-platform or anything else. And the way the entire framework was built was completely different, right? And it was a proprietary thing, if I can call that way, right? We don't have any idea about how the framework is implemented. But .NET Core, when it was started, I think it was back in 2016 or 15. I'm not sure about the numbers. Sorry about that. But yeah, but it's a completely open source, and it's completely cross-platform. So that means with .NET Core, you'll be able to run your web API, right, in either on your Linux machines also or on Mac OS machines also, right? So if you want to host your API in a server on a Linux server, you can very well do that. And if you have to you have to use .NET Core for that, right? So this was until .NET 5 came in, right? So and we always are, a lot of us always had this confusion, or people coming new would always have this confusion about should I choose .NET Framework or should I choose .NET Core, right? And that's what is kind of addressed now with .NET 5. It's all unified now, so there's going to be only one .NET, which is called .NET 5, and then it is going to be again .NET 5, 6, 7, etc. And there is a neat cadence of release and everything set up in GitHub in the .NET repositories, right? So I've been talking about .NET as open source, right? So what I mean by that is if you go to GitHub, and then you can go ahead and search for .NET, right? And then you will see all the repositories which is present within .NET. Right? Your entire .NET runtimes, and then your core effects or the framework level things, etc. Everything is built in open source here, right? So that also brings good amount of visibility on what are the features that are being worked upon, and then what are the release cadence, etc., etc. I hope that answered the question. And you need to create Swagger's file or something. It is created by Microsoft. So how the Swagger file is generated is using this particular library, right? Do you have that open? Yeah, let me open with the basic ones, but it's easier. So here, if you look at the project, right, we have added a NuGet package called swashbuckle dot whatever that package in swashbuckle.ASP.NET Core, right? So this package, what it does is it has an implementation. So it will read through the controllers here, and then it will automatically generate that particular API spec for us, right? So it's an additional thing. It's not out of the box in ASP.NET Core, but this is added as part of the API template. That's how you will get it. And one, if you want to do by yourself, you can create a blank solution and start a new blank C# project. And then we need to start adding these different NuGet packages into it by running .NET add package and then mention swashbuckle.ASP.NET Core, and then you would get that functionality. Once you add it, you also need to go ahead and enable that swashbuckle in the configuration space here. Right. So if I comment out this particular these two lines, we will not get that Swagger available for the microservice or for the API. Okay. Yeah, can you paste example clone link? So basically the link for this entire thing and the learn, I pinged that build your microservice learn link, so you can just navigate from there. Does .NET Core support identity server inbuilt? I don't think. I think there are different talks about around that. I think it's from .NET 6. It's going to be made as a separate package, if I'm not wrong. I'll get back to that later. Okay. Okay. Yeah. So now moving on. Let's get back to the sessions thing, and then I'll take further questions after some time. All right. Okay, so where were we? So we were in the front end and back end application, right? So now what we are going to do now is we are going to, so we just saw how this application works in my machine, right? I'm using a Mac here, obviously, so you can see that .NET runs on Mac also, right? Now what we are going to do is we are going to create a Docker image for this front and back end application first, and then let's run through that in Docker, right? So for that, go into the backend folder. If you go to the backend folder, you can see something called Docker file, which will be blank file. That's what you will get as part of the repo, what you cloned, right? Oops, sorry, let me take a step back, right? So before I get there, I'll just walk you through about the code structure here so that you're comfortable when you want to follow it up, right? So the backend is where the backend APIs are. This is almost or exactly similar to what I showed as a basic API, right? As in .NET new microservice what I created here. The controller name is pizza info controller. That's why I had to access this via pizza info endpoint, right? So this part is something which we've already seen. So another part is the front end, so which is built using a Razor Pages application. So here also you will see front end a CS proj, which is it's a web application. So that's why it's called web. And then we have all other different things available here, right? So this needs whatever the container tools related for front end project, which is what is mentioned here. And this startup would look a little different. So here, as you can see, services.add Razor Pages we are doing. That's how when the host is created, it will know what kind of workloads it needs to add, right? In the backend, you will not see this one, right? You will see something called services.add controller. So if I open that other startup CS, right? So you will see that this is having services.add controllers, right? That's how we can differentiate whether it is an API project or a different project. Just give me a second. Yeah, sorry, kids around. So yeah, so this is what would be a difference between different kinds of projects. The startup would be different, right? This would enable whenever the host builder is creating the host, it will know what kind of services to be configured when it builds it, right? And since this is a front end application, we're also trying to get the backend URL, so which is what is mentioned here, or what is that? App settings.json. Okay, backend, sorry. So front ends, app settings, development JSON. Yeah, here's where we have defined the backend URL, and this URL is what will be configured with the client when it tries to make the API call, right? So here you might be wondering why there are two different files. So app settings.json is like is the base one, and then these are like environment specific variables, environment specific configurations. So whatever environment you're running, it would these settings will be overwritten with the values present in that environment specific files. Right, so here we have specified as backend as this one. So that's how it will establish the communication to the API, right? So if I can show the, I think I cleared it off. Yeah, if you notice, I think the endpoint, the URL was localhost 5901. That's where the backend was running. So that's exactly what we have configured here, right? And yeah, so and this here is where you create all your static things about CSS or JavaScript things if you want to add. And the pages is where we define the pages. So now index.cshtml. This syntax is called Razor if you're pretty new to it. So that's why it's called Razor pages. So these pages are built using Razor syntax, right? It's more of a markup, plus you can also add code pieces to it, right? So this is a pure markup, what we have, like a pure HTML markup. And here is where we are embedding the model. So for example, this @ for each. So basically, if you look at it, there is this model called index model, and that's where we have defined the entire data set and everything. And that's bound here basically using a for each here, right? So that's how you can see that entire page is showing up in that tabular format. It's pretty simple, right? But it's more powerful, and then you can build a lot of custom UIs and everything with asset pages too. All right, so now we're getting back to our core thing, right? So now let's go back to our Docker file in backend, right? I'll open this, and then whatever you need to add to the Docker file is also mentioned here in the tutorial itself. Just for so it's straightforward, we'll just go ahead and copy from there, and then I'll explain what it is doing. Right. So in any Docker file, the first thing what you would see is a from statement, right? So what does it mean is from basically Docker works on concept of layers, right? So what you will use as a base is what you will specify here, which is nothing but this .NET-SDK is an image name, and this image is available in this repository, which is ncr@microsoft.com, which is repository is nothing but but a place where you will go and push your images, right? Like if it's a NuGet repository where you will push your NuGet packages, or Maven you will push your jar. On the similar lines, this is where you will push your Docker images. So Docker images is a pull from here. This is the image name, and this is the tag of it, and this image is named as build, right? And then we are setting the working directory as a source folder, and we're copying the current backend CS project, right? Because it's within this particular folder structure, it can understand the backend CS project. We are just copying that into the current folder, which will be /src, and then we are doing a .NET restore, and we are copying the output of that, and we are doing a .NET publish. So basically, .NET publish would trim unused dependencies and things like that. That's why when you try to run your application, you may make sure we are trying to publish, and then we are publish, and then publish in a release configuration, and then it is pushed. So this is just one part of it, right? Docker also has something called a multi-staged build. That means you can do multiple things in a single Docker statement, right? So now at the end of it, if I just put it, right? So what we are trying to do here, right? See, when you want to build your application, you would need different set of components there. That's where you need an SDK. But if you want to just run your application, you don't need the complete SDK there. All you would need is just a runtime which can understand the compiled code, and then it needs to run it, right? So that's where this particular image comes into picture. So you can use microservices.com/.NET ASP.NET 5.0, and then we are trying to run this app, right? So from where are we getting this app? We are taking it from the build. So this copy from build, right, means whatever we have published as into the app folder in the first step, in this particular stage of the .NET, in this particular stage of the Docker build, that output would be used here, and then we are adding that into, or we are copying that into this particular container, right? And entry point is nothing but whenever this container starts separate, what it should do, because every container when it comes up, it has to do one thing, right? So you need to specify what is the entry point for it. So now we are telling the .NET process to run this backend DLL, right? So this is similar to .NET run backend.dll, right? It's exactly the same as what would happen within a Docker container, right? So now with that, I think we are good with the content here. And now to build your Docker image, right, you will use this command called docker build, right? So let me pull up the terminal again. So since I'm in the backend folder, I'll just say docker build -t. So what we're doing is docker is the CLI what we are using, and then build is a command, and -t is nothing but the tag name. So I'm telling it to name this image as a pizza backend. So this dot is important. That's the workspace from where you need to run this build. Because we are telling dot, these references will become directly easier. Right? If you are running this build from a different folder, you need to ensure you give the working directory appropriately, right? So when you do that, you will see a lot of things happening, right? So basically, it runs the steps in the order of steps what we have mentioned in the file here, right? And if you're doing for the first time, it would take quite a good amount of time to pull these SDK, on these images. Since I've already run it, it is able to reuse the same thing what's present in my machine, right? And then that's why the build is a bit relatively faster, right? Okay, so it says it's still trying to build. Yeah, so now we have the Docker pizza backend is available, right? So now to check whether the images are created, you can just do something called Docker images, and then I'll just say pizza. So it should pull up this. So pizza backend is what we have just created, right? And that's what is showing up here. Right? I mean, forget about the other ones, which since I was trying yesterday, I have all these, which I'll explain later, right? So now we've got the image, right? Now, how do we run this image, right? So that is something. There's a command for running that image. So which is this? I'll just quickly copy it, and then I will explain what it does. So Docker is again that CLI, Docker CLI, and then we are selling run, and IT is nothing but in interactive, and then we are just trying to remove it once the container is stopped, right? So this is important here. 5200 is the port, is my local port, the machine which I'm running, right? So this is my local port, and then I'm mapping the port where the container port of 80. So here, if you look at it, we're exposing only the container port, right? So every container will have its own networking ports, right? But on the host level, there is only one port, right? My machine can have 5200 as only one port. I can't have multiple things running on 5200, right? So if you want to host multiple applications, you need to ensure you map them appropriately in different ports, and then you can run, right? So yeah, this is the name of the image, and then the, say, basically the container name, and then this is the image name, right? When you do that, it should run the container, and then we should see this available here, right? So this is a container log, so it will say it is running at or exposed at 80, right? But what we would need to do to browse this is to use localhost colon 5200, because that's where it's listening, right? So I'll just go ahead and change this, and yeah, so as you can see, if I refresh more, it's able to return this, right? So that's how you would be able to dockerize a particular microservice or a container, and then microservice, and then run it in a container, right? So this is the first step in dockerizing anything, right? And there are other tools and extensions available in VS Code also, right? So I've installed, if you can see in the left, there is something called this Docker extension, right? You can use these if you are a fan of GUI and then getting things in a visual fashion also, right? So if you click on this image, it will show whatever the different containers which are running. I think I just stopped it, so it's not showing it. Basically, otherwise it will show all the containers, whatever is running, etc. here, right? All right, I think quick time check. Okay, I just have only 10 minutes. Considering that, let's move on to the next part. So this is about just one container, right? Now let me go back to the presentation to talk about the orchestration, right? So now, but this is good only when we learn, and then when we are trying to get ourselves in the first step, right? But in a typical enterprise world, or even if you want to build a smaller application, you would have multiple microservices for sure, right? So how do you ensure a particular, let's say in this case only we saw front end and back end, right? So how will you ensure the front end is able to talk to the right back end, and the front end is having the right dependency as a back end, right? Before the front end container comes up, we need to have the back end up and running, right? So how do we handle all those, and then also there are multiple other things which should come into picture, right? So that's where this orchestration is important, right? So for now it's okay, but this is exactly what I'm trying to tell here, right? So, and if you want to orchestrate multiple microservices, there are different tools and technologies available, and the simplest one is to go with the Docker Compose, which could be very well used if you're having limited set of containers, and then if you're expecting limited set of functionalities out of an orchestrator, right? If you're looking at a more full-fledged orchestrator, I think Kubernetes has become the de facto standards now, so then you might need to run in Kubernetes, right? So basically, orchestrator is nothing but it will ensure you are able to run your application with the right dependencies in it, and then it will ensure the right networking is enabled for the communication of your microservices, etc. Right? I think this is what I just told, and then yeah, Docker Compose is what we would use now, and then see how we can bring up both our front end and back end together. Okay, I'll not do that knowledge check now, considering the time what we have. So I'll go back here. No, not this. Go back here, and then let's bring up this one. See, this is wrong. Yeah, this is the one. Sorry. Right. So now, if you look at this project, there is something called Docker compose file. Right. This is what we are going to write now to populate the or to create the Docker compose basically. Right. So we'll go next here, which is the orchestration. So basically, you can go through this at your leisure too, and then just follow through the steps. Ah, okay. Thank you. And yeah, so let me copy paste this, and then I'll explain what I was doing. So the docker file is more like a text file which has all these commands followed by its corresponding arguments, etc. Right? But compose is an YAML file, right? So where we will define, this is the version of the docker compose YAML file. So services is where we will create the different services. So in this compose we are creating two services. One is called front end and the other is back end. Right? The front end is coming from the image called pizza front end image, and then and how it is going to be, this image is going to be created is by doing a build. There are different ways you can bring up docker bring up an image. Either you always build it, which is what we will do when we are doing development, but when you are trying to deploy it and run it in a test or in a prod workloads, etc., you would pull the image from a different repository or so, or from the Docker Hub or any other image repositories, right? So here, since we are doing in the local, it's going to be the Docker, it's going to be via the build, and then the context is the front end folder, because like I said, context is very important. This Docker compose is outside, so it will go and look for the Docker file inside this front end folder, which is present here, right? And then the environment, see, if you look at it, this is the environment variable which we have created, which we have looked at in the app the settings of development JSON, right? So backend URL, when we are learning local, it was able to pick this, but when you run from Docker, you cannot use this one, right? That's where it is going to tell that the backend URL will be from the backend, it's a service name here, right? Now, where is backend? That's what is mentioned here, right? But before we go to the backend, so these are the two port mapping what we are doing. Basically 5902 and my local is getting mapped into 80. And this is the important step here, right? So this is how you will manage the dependencies, which is depends on backend. So that means when you run this Docker compose, it will ensure the backend container is up and running first, and then it will run your, or it will try to bring up your front end container. That's how you can manage the dependencies, right? And then this is pretty much self-explanatory now, since we just talked about the front end, right? Now to create this, what we need to do is we need to run Docker compose. Docker compose is also another command line utility you will get when you install Docker, right? There are two commands. You can do a Docker compose build to just build these images, or you can also do a Docker compose up to bring your containers up. So up will ensure it's able to build both of these, and then it will bring up the backend container, and then it will bring up the front end container. All right, this is done here. Let's see here. Let's say Docker compose and up. Right now you should see it is starting this backend and then this front end also, right? Both of them are running, and we should be able to access the front end using 5902. Let's go ahead and check that out. 502. Yeah, there we go. Hooray. So first step complete, right? So we are able to get our microservice. We are able to get this piece application a microservices fashion by having a dedicated or separate front end and the separate deployment for backend. And we were able to orchestrate it using a Docker compose, right? So now, since these two are running, if you go to this Docker Explorer, you can go ahead and see that this should be running. See? This is how these are two containers which are running, and this also gives you the ability to look at the files, whatever is present inside the container, etc. This is pretty there is a, we can also talk about this extension itself for about an hour or so. There's a lot of cool features in it, right? So that's pretty much about the container orchestration using Docker compose, right? I don't think we would have time to talk about Kubernetes because we just have 5 minutes. So let me go back to the teams and then check if there are any questions. Okay, where is that? Okay, how Docker file is coming here? Did we create it? Yes, you can create a Docker file. We have to create the Docker file, and we did create it. So basically, it's part of the repository which I cloned, so you could see the Docker file was already present. If it's not there, you can directly create. You can just create a new file and then say a Docker file, and then it would be created. And the naming is important. It has to be in this naming convention, Docker file. Okay. Some question, if you have used Windows machine for demo, that would have been great. Oh, I'm so sorry, I'm currently using Mac. And the other idea is also to tell that it's also that .NET can be running anywhere now, because we've all been, I was a Windows user quite some time back. We use Visual Studio there, and it's not that Visual Studio is, or .NET is tied only to Visual Studio, right? You can run without Visual Studio also using VS Code and any other editors too. Right, so that's, and it's easier to use this, is lightweight. If you want a full-blown IDE with a lot of debugging capabilities, monitoring capabilities, etc., yes, then you can use either Visual Studio on Windows, or you also have VS for Mac. So you can use one of these to get those features. But basic debugging, troubleshooting, everything is possible with VS Code itself. Okay. Can you highlight more on service resilience, handling failures, etc.? Yeah, so that's a good topic by itself, right? So since we are just touching scratch of the microservices, I didn't want to get there, right? But what I would like you to share is, if you go to this .NET documentation itself, right, there is this architecture section, or not in the documentation. If you go to .NET .NET/architecture, if you go, right, you can see the entire architecture things are available. So .NET/architecture, where there are a lot of architecture free ebooks are available basically, right? Depending on microservices or Azure Cloud Apps or DevOps or whatever be the things, right? And these are pretty much available for all of us to download and look at it. And if you go to this microservices thing, you either download it or you can also view on the web. And this has good section about the handling resiliency and things like that. Okay, maybe we could do a further follow-up session on it if that's an interesting topic to cover. Okay, I think another question is, can you please give an example when we use SDK and when we use ASP.NET Image? I think I talked about it. SDK is for building your application and runtime, and ASP.NET Image is having the runtime, and you would use it only when you want to run an image. I think somebody answered it. Yeah, thank you. Oh, which language is better? That's a debatable topic, right? It has a lot of factors into it. If you have a team who's already skilled on Java, you can continue building on Java Spring Boot based, or if you have a team already familiar with Node.js, you can do that. If you want to, each one has its own goods and bads, right? So yes, this is specifically for .NET. .NET, like I said, if you learn .NET, you can run all other workloads also. So yeah, that's where it is. And if you're looking at the performance benchmarks, please check the Tech Empower's performance benchmarks for ASP.NET Core, and that will give you a good understanding of why ASP.NET is faster, and then how and why we can use ASP.NET for building microservices, etc. And does the Docker is running on a local machine? Yeah, I think I didn't show that. So this is the doc. When you install Docker desktop on your machine, you will get this running. So this is available on both Windows and Mac. This is nothing Mac specific or so. So along with Docker desktop itself, you'll get Kubernetes also. So ensure you have that also running, so that you can do everything in the local machine itself. Right. So to build and run things in your local, you don't need to push the image anywhere else. What I mean by push is to pushing into a remote image registry, right? The moment you want to deploy into Kubernetes, it only then you would need to pull the image from an image registry. So is it possible to see the list of DLL files inside the image file created by Docker? Joe has asked that question. So if at all we have to do that, we'll have to use these Docker extensions in the in here. I think it's stopped now. Let me see if it's still able to run forward. No, it's not. Let me bring it up soon. So basically, yeah, this extension would allow you to browse through the files inside it. If you go to the files, I think our folder should be app folder. Right, so this is the entire publish output what we get out of an .NET publish command, right? This is what is seated inside this. Now if you go inside the app settings.development.json, you should be able to preview that as well. I think it's taking some time to pull up from there, or I need to open it there, download, just say open. Now it's available to open. Yeah, so basically, yeah, this is how you can browse through the Docker container. Okay, so one question on port mapping. I know it's 7 o'clock already. So Rashmita, can we continue for another couple more minutes and answer these questions, or how is it?
Yes, please, you can continue.
Okay, great. Yeah, so maybe then I'll go through these questions and then answer them. Right, so port mapping, right? Yeah, so that's a good question. So like I mentioned, every application runs in its own container, and each container has its own container port. Okay, so this what you see in the right hand side is a container port, right? If you go to this ports also in this extension, it will tell host : container, right? So you can run any applications in port 80 in the container, but that 80 is not directly mapped to the port 80 in my physical machine here, right? That's how we are able to run. That's how we are able to deploy all of them in its own 80 container port. Excuse me, and we're mapping them into a different port here in my local machine. So the significance of port 80 is, so basically the port mapping, what you do here should be same as what you mentioned in the port number should be same as what you mentioned in your Docker file, right? By default, not all the ports are enabled, right? You need to explicitly expose like this. So here to enable HTTP and HTTPS, these two ports are exposed, right? Port 80 and port 443. So because 80 is only exposed here, we are trying to map that port, container port 80, into my local port 5900. Let's say, for example, if I am exposing my application in a local host 5000 or something like that, right? Then you would need to expose the port number as 5000 here, and your mapping also would change it to 5000 here. Okay, so what you see in the right is the container port, and that could be any port. And when I say any port, it could be the same port what you're exposing as part of your Docker file. Okay, so will we maintain different Docker file for different environment or environment specific configuration? How do we manage app config for a Dockerized app? Okay, that's an excellent question. All right, so here also, if you look at it, right, basically the short answer is yes, the Docker file will be only one, right? And then you'll have to pass the environment specific values appropriately, right? And it can be done in different ways, right? So one example is here in the Docker Compose itself, we have this environment variable, right? So this is how you will configure. Tomorrow, if you want to, let's say, run for maybe for Docker Compose, you might have different Compose YAML files, because this has the environment values injected here, right? This could be only for the dev. And for the prod, if in case you are trying to change your backend endpoint, you would go ahead and update this, maybe call docker compose prod.yaml, and then you'll run that for your prod deployment. But you would need to isolate your image creation with a Docker file, right? Where it should have only your base image. Base image means the dependencies from where you want to build your image, right? Those things plus your application specific things. All these configurations should be externalized. And there are different ways you could do that, and it would also be part of your CI pipeline or CI/CD pipeline, what you have it, right? Let's say if you're using Azure DevOps for that matter, as part of your build tasks, you can also specify some of these environment variables, and that will get injected as part of the build. Will this recording be uploaded or shared and uploaded? Yes, it would be. You can try to apply to Kubernetes without more explanation. Okay, sorry, I think I did take time to explain already. So if you guys are still interested to see the Kubernetes part, it is straightforward. I tried to create some notebooks so that we can run that faster too. But I'll just get to that after handling questions. Okay, what about service discovery, services, and distributed logging and tracing? Yes, those are very much important things to be considered when you're working with microservice architecture. And there are different ways to handle each of them. There are different frameworks available to handle each of them. Right, for example, service discovery, if you are using Kubernetes, right, Kubernetes automatically has its own kube DNS available inside, and then you can internally the microservices can talk to each other, right? And for distributed logging, for example, there's something called Zipkin which you can use, or if you're using any other observability platforms like Datadog or something else, you can also inject them, and then you can get the benefits out of them. Right? And for service discovery, like I said, yeah, we can use other frameworks like Steel Toe and other things which can be used to enable these aspects. And what is the difference between Swarm and Compose? Okay, so Docker Compose is more like is an orchestration tool, right? But where the actual infrastructure where it will run is a Docker Swarm. You can think of Docker Swarm is something equivalent to a Kubernetes cluster, right? Where you'll have multiple Docker hosts available in different nodes, and then all of them are connected with connected together, and that's what is called a Docker Swarm. So you will use Docker Compose files to deploy your microservices into Docker Swarm. How database connectivity managed in microservices? So like I said, it's about database basically one database per service kind of an approach, right? So you would have your own database created for your microservice, and then you will provide that connection strings or whatever into your application configuration, and we can use them. So connectivity, talk about connectivity, it's again, there are multiple things to consider here. So if in case you are running your database itself in a container, right, then you would use either the Kubernetes way of internal service discovery, or Docker Swarm, or Docker Compose way if you're using Docker Swarm, etc. Right? But if you're using an PaaS offering, like let's say an Azure, you can use Azure SQL or Azure Cosmos for that matter, right? If you're doing that, you would be providing that particular connection string. So handling the connectivity is really dependent on how we are trying to manage our databases. .NET 5 microservice support bidirectional streaming as gRPC. Yes, gRPC supports bidirectional streaming. It's very much possible. And so all three layers of an application can be deployed into independent microservices with their own Docker containers. Yes, technically, if you want to convert your three-tier architecture or three-tier architecture into microservices, yes, you could do that. Front-end could be deployed in a different container. That's what we just saw, right? Front-end is in a different container, back-end is in a different container, and then if you want DB also, you can bring up DB in a different container. If you want to use some caching, you can also put some Redis cache or whatever, and then you can bring that in a different container, or you can also use some of the Redis offerings in Azure, right? So options are numerous here for us. Okay, so could you explain the Docker file again? I'll just get to that. And Docker, okay, quick demo on link to Kubernetes. Okay, so let me talk about Kubernetes now, right? Since quite a few people have asked about it, right? So let's go back there. And sorry, before that, since I'm a Docker file, I'll just quickly explain. It'll just take less than a minute or so, right? So this is a multi-staged build. That means you are trying to run multiple stages of your Docker builds here, right? Only in such cases you would use something like this, because you want to use the output of this first image into the next stage here. Okay, so here what we are trying to do is we are pulling the base image as .NET SDK 5.0, and then we are setting the work directory. Basically, this will tell where it should start running the looking for the entry points and etc. Right? We are telling it is as /src as the folder, and then we are copying the backend.cs project into this particular /src folder. Okay, so this is basically an intermediate container you can think of. Okay, what this will do in the multi-stage build is this will create an image, and then it will just use that image here, and finally whatever we have would be see, that's why if you look at in the Docker Explorer here, right? If we open, we don't see the src folder there, right? What we see is an /app folder, because in the final container where we are running the application, we have created the folder structure as /app as a working directory, right? So .NET runtime would look for the backend.dll inside this /app folder. So that's what we are trying to mention here, right? The reason we made it as multi-stage is because we don't need to use. See, basically, when you want these containers, right? They are transient, right? That means anytime container can go down and then they can come up, right? And when they come up, you need to ensure they come up very fast. They come up in a much faster pace, or as soon as possible, right? That's the reason we don't want to carry a big baggage of the base images, right? That's why we are trying to ensure the runtime is very lightweight, right? So that's one of the reasons why we are using a two-staged or a multi-stage build here. Okay, and since this is where the application is, this is the image where the application is going to run, we are having all these expose commands here, right? So if you ask me, technically you could very well do this also, okay, before running this, after running this, right? So you can technically, you can just directly say publish this, and then you can copy directly the app into the container. That would also work, right? But like I said, for the reasons of ensuring your application startup is quicker, right? We don't want to do the entire build as part of your thing. What you will do is you will just have only the entry point. So we are separating the building part into another stage, and then we are ensuring the running part is happening here. Okay, where was I going to do? I think we were going to talk about Kubernetes, right? Okay, maybe I'll just take 5 minutes and then explain about that. So yeah, to keep things simpler and easier, I also I did use another extension. So for Kubernetes, right, for people who are interested about Kubernetes, we need something called Kubernetes YAML files, right? So you need a deployment YAML where you would create deployment. So basically what you have as a Docker compose where you are telling what is the base image and then where it needs to create and what is endpoints, etc., right? That's what you will create in a deployment.yaml file, right? There are concepts like deployments, services, replica sets, and pods. So you need to be mindful of these. So pods are the ones where the actual, what you call as a Docker container, right? It's called a pod there, because a pod can have multiple containers in it, right? So you'll run your application in a pod, and then that pod would managed to be a deployment, and the deployment also has something called replica set, and that's how you will attain. Let's say if you want to scale your application from 2 pods to 5 pods, right? That's why the replica set would take care for us, right? And this is just about deployment. And for us to expose this particular container or a pod to an outside environment, or even for anything within the Kubernetes, we need to create something called a service. Right? These are the two things which we need to create to get our application up and running. Right? So let me quickly grab the Kubernetes YAML files. This is also present in a gist, right? So this is for pizza backend. I'll go ahead and paste this here. So now if you look at it, right, so this is an Kubernetes YAML file. It's of kind deployment. It's called Kubernetes manifest. Right? We're telling we want to run only one replica here. And this is the metadata, and we named the app as pizza backend here, right? And the specification is where we specify what are the containers. So here we are going to have only one container, which is called backend. And then the image is coming from niche/pizza backend. So I've used niche image, which is still available in Docker Hub. Right, so for deploying anything into Kubernetes, you need to push your image, local image, into a remote repository. Okay, so that's not already done in this image, so I'm just using that. And here is where you would pass the environment variables here, right? For Kubernetes. And then yes, these are the environment variables what we have, and yeah, that's about it. So this is about the deployment part, right? And now what we would do is we would need to create a service, which is this kind service, and the service name is backend, and the port is 80 here. That means we're just creating a port with 80 here, right? We're not exposing this outside basically, because this is something which will be internally consumed by the front end, right? And similar way we have front end deployment YAML. I will quickly grab that as well. So just copy that and put it here. It's pretty much the same thing. And here we might have, see, now you can see this backend URL. Forget about the squigglies. Here I have this extension for Kubernetes, so that's doing some validation and then showing this. But I hope you are able to see see these pieces, right, where the backend URL, which is an environment variable for ASP.NET application, is mentioned here, right? And this is the pizza front-end application, and here is where we are exposing it. There are different types of services are available. Load balancer is what would enable you to access outside of the Kubernetes cluster, right? So here I'm using my local Kubernetes cluster, but if the same thing would be applicable in any of the Kubernetes cluster you want to, be it on AKS or GKE or whatever it is, right? So now just to what we need to do is we need to run these two things, or we need to deploy these two things. So for that I've created these notebooks. So this is another extension in VS Code where you can use a notebook to get your basically it's a Python notebook, Jupyter notebook, and I am using that to run the commands, right? So to deploy the backend, you just need to click this cell. I didn't want to make any typo errors or something. So I hope this would run. It's connecting to the kernel. So basically you'll say kubectl apply. That means it is going to apply these changes, whatever we have defined in this YAML file, right? And then it will create the deployment. So as you can see, it says deployment is created. Now you can also do a deployment of front end, the same thing, right? And it should say, yeah, deployment is done for the front end also. Now if you look at the get pods, you should see pods running. Since we mentioned only one, it says only one replica here, right? If you had mentioned two, it will create two replicas. So maybe let me quickly rerun this to see. Yeah, so now both of our pods are running, front end and back end. And you can also look at the service, right? If you look at it, we see this pizza backend, which is a service. It doesn't have any external IP because we have not made it as a load balancer, right? The default type of service is cluster IP. That's why it created a specific IP for that particular backend service. And front end, we see it's a load balancer, and then the external IP is localhost. That means with localhost, I should be able to access this particular front end, right? But what we are doing again now is we don't have an ingress created. So what we are trying to do is we are trying to do a port forwarding of that front end service to my particular 4900 port here. So now if I do this, it will start the pizza front end. And now if we go back to the browser and say http colon localhost colon 5900, I think I should do http, not https. Oops, what happened? Did it happen? It says it's handling connection. It should come up. Oh, it's taking HTTP again. HTTPS again, sorry. Yeah, so the pizza app is here, right? So now this is accessed from Kubernetes, right? See, since it's port forwarding, it will every time I refresh, it will keep talking. It will keep logging that particular thing here. Yeah, that's a quick demo about running this in Kubernetes. I know it's pretty fast, and there are a lot of things you need to know about Kubernetes, but I think you have got an idea. All right. Are there any other questions? Thank you so much for those comments. And yeah, please use this feedback survey and then provide the comments so that we can do better in further events.
Hi, Swaminathan. Tirupati here. I have a few questions.
Yeah.
See, usually the load balancer, right? So, you said right, Kubernetes will create a image, Docker image based on the client, I mean, the customer loads. For example, at the peak time, the user may get access the particular pieces more than 100. So, how we are creating the Docker images? So, do we have any configuration like more than 100 users? We need to include the images. How we need to be configured?
So you're talking about the dynamic auto scaling part, right? If I can put it
Yes, you're right.
simply.
Yes,
Right.
you're right.
So there is something called an horizontal pod autoscaler in Kubernetes. Okay, Kubernetes. That's why Kubernetes is kind of a de facto. It has become a de facto orchestration tool, right? There's something called horizontal pod autoscaler, which you can also enable, like what we have created as two different manifests now, right? I know I just stopped sharing. So we have just deployment and service, right? On a similarly, there's something called horizontal pod autoscaler, where you can define the limits. Let's say if your memory is used beyond 80% or 90%, right? Then you can tell how many additional pods it needs to spin up, right? So this or autoscaler will keep on working with the metric server and then pull the details about individual pods, and then the moment it finds yes the memory usage is growing beyond the threshold, it will automatically spin up your new pod. And you can also give rules to bring it down also. That's why we call it scaling up and scaling down, right? So you can also scale down to whatever the number you want to have it as a base minimum number of pods, because you need to implement a HPA. Yeah.
Yes. Okay, thank you. That's what I'm. Okay, thank you.
Yeah. Thank you. Okay. Anything? Any other questions? So I think I kind of tried to cover all the questions. I'm just looking at the chat window again.
Hi, this is Sam.
Hey, hi. Hey, you have a question?
Yeah, actually, for example, I have 100 pods are running at present. So I have only one database as a production database, right? So how these connections will be made? So to the 100 pods synchronously calling the same database, will there be a heavy load, right, for the particular database? So how these
Correct. Yeah.
connections will be handled?
See, it's all about how it's about the connection pool, right? How we are handling it. I don't know about which. I think it's a .NET application, or I'm not sure. So that is something which we need to handle it on our application side, right? Because there's only so much what a database can also handle, right? So if you're having 100 different microservices talking to a single database, that's not really a good design also, right? We might need to also relook at if we can create different databases for these different microservices and then do it. Or if it's a single microservice with 100 pods running, then also it's about the connection pool, how we have set up as part of our code, right? Because when these are very subjective things, right? We'll have to look at, we can't simply create new connection for every database calls or something, that you need to maintain a connection pool, or use some sort of or use connection pool or something like that, and then ensure you are not creating a lot of connections, and then the database shouldn't stop terminating or start terminating further connections from your application, right? That's something you'll have to handle at the application level.
Got it. Thank you.
Yeah. And what is the best practice so that we don't create a lot of microservices for every feature request? Okay, yeah, that's a good question. See, when we talk about microservice, one of the important things is bounded context, right? So you need to understand from business domain perspective what is the context of this microservice, what is it we are trying to achieve by in this microservice, right? It's not that for every feature you would create new microservice, right? You need to look at you need to find a logical boundary, and then see if you're able to seal all the operations or the features within that boundary. So a classic example would be to take an e-commerce portal, right? You'll have search, you'll have product landing page, or you'll have orders, you'll have checkout. These are different functionalities which all compose an entire e-commerce portal, right? So you'll have to look at that perspective. It shouldn't be like within your search itself you spin up multiple other microservices. I mean, there is no single rule of thumb for that, right? It's all about that's where when someone is doing a microservices design, right, they need to look at the overall business boundary and then see how we can logically split them and then make it in a manageable fashion, right? Because creating microservice is easy, one or two, but like someone asked now, if it's become 100 or 200, right, then you need to start thinking about something like service mesh on top of it, right? So things would get complicated as you start dealing with hundreds or 200s of microservices.
Like in continued, Swami, hi, this is Manu. Like I had the question which is continued from the previous question. Like if we, if the nodes get scaled in, right, even the databases will also be scaled. That was my thinking, because only if we scale the microservice part, and if we keep like only one database of it, then it might end up
Correct.
like you have too much of front end, but your database gets hanging. So
Correct.
will the database will also scaled when you create a new pod or scaling?
So see, it depends again on how we are handling the database, right? Like I said, if you're running the database itself in a container with a storage set or stateful set manner, right? Then it's possible. Or if you're using a PaaS offering, for example, in the Azure, if you're using Azure Cosmos, right? It deals with request unit per se, right? You have to configure the request units per second, RUs they call it, right? Depending on that, that's the maximum what a database can take. Anything beyond that, it will start telling rate limiting error. You will get something like error 429 where it says request is too large or too many requests at the time or something like that, right? So you need to think holistically, right? It's not just about only scaling your front end, but if your backend is not capable of doing it, then there's no point of just having the front end alone running in multiple instances, right? So when we talk about scaling, yes, the easier way to do is to put an HPA or a horizontal pod autoscaler, but we'll have to look at all the layers or all the different dependencies if they're able to cater to that particular scale. Yeah, only then we'll be able to achieve the actual scale.
Yeah, that was the yeah. Thank you.
Yeah,
Thank you.
yeah. And is it best to use AKS instead of creating all from scratch? I mean, I'm not sure if yeah, you can use AKS. Definitely, it comes with a cost, right? So if you're experimenting, I would recommend you can use local instance of Kubernetes, and for production workloads, obviously yes, you can go with AKS. And yeah, that's a different topic altogether. Application Insight plus K8s. Is that a question, or I'm not sure? Okay, I think we've gone past by a lot of minutes, and thank you so much for sticking around and asking wonderful questions. I hope you guys like the session. So please provide candid feedback so that we can improve on the content or whatever the session and things like that. Yeah.
Thank you, Swaminathan, for the session, and thank you all for joining us today. I have shared the link to our feedback survey in the chat. Do send your feedback. It will help us curate topics that better suit our audiences. Also, if you have not done the event check-in yet, please feel free to do it. Please visit Microsoft Reactor Bengaluru meetup page for more session. Thank you all once again.
Yeah. Thank you so much, everybody. Thanks for taking time on a Thursday evening if you're in India, and then spending time with us and learning things. Appreciate it. Thank you. Stay home. Stay safe.